Welcome to another episode of the Geotechnical Engineering Podcast. In this episode, I'll be talking with Leonard Sands, who's a global business line director for land at Fugro. We'll be talking about his extensive career journey, the evolution and innovations in land site characterization and geological data gathering. I'm your host, Jared Green, and I'm excited to be bringing you another episode of the Geotechnical Engineering Podcast. But before we get started, we're going to hear a word from our sponsor for today's episode.
This video is brought to you by Menard USA. Menard USA is a specialty ground improvement contractor that works nationally providing design-build ground improvement solutions at sites with problematic soils. Menard works closely with civil, structural, and geotechnical engineers to minimize foundation costs for wide ranges of soil conditions, structure types, and loading conditions. To learn more about Menard USA or for help on your next project, please visit www.menardusa.com.
All right, Leonard, welcome to the Geotechnical Engineering Podcast. How are you doing?
I'm brilliant. I'm great. And thank you for the warm welcome to actually be with you today. I appreciate the opportunity to share part of my journey with you.
Excellent. Well, I love that. Love that you could be here with us. And it just set the stage for us. If you could talk a little bit more about your career journey, and tell the listeners and those that are watching how you progressed from your academic studies in civil and geotechnical engineering to becoming the global business line director for land at Fugro. And also let the folks know where you're calling in from. I think that'll be interesting for folks.
Sure. Well, today I'm in Leidschendam, which is a town or a part of the Den Haag city in the Netherlands. So that's, in Europe. If those out there want to get a reference, we're sitting in Europe and we're across the pond from the UK. That's a good reference for you. So, I'd really like to share my story. And if you've got a couple of minutes, I can actually take you on a bit of a journey.
Take us on the journey. You can give us the long version. We got time.
So I think everyone out there in the geotech industry, we have definitely a connection with the outside world. We love to be outside. We love to actually feel the soil, like to touch it. And in all of us, there is this sense of adventure. I think that the unknown and what lies beneath the earth is always in our minds. In fact, we can visualize it better than most people.
Yeah.
Hence why we're where we are. But for me, it started when I was a child, around 10 years of age. I left New Zealand, which is my birthplace, and left on a yacht to sail around the South Pacific. And that was a journey that really transformed my whole life and was one of my fundamental experiences, which connected me with nature, connected me with what's out there beyond the horizon. That experience got me exposed to nature, to the ocean, the vastness of the ocean, culture. It got me exposed to the weather and how that can influence life. Through that journey, we ended up sailing through all of the islands of the South Pacific, Vanuatu, Solomon, Papua New Guinea. And in the end, the journey kind of stopped after 1 year in Australia. So at that point, it's kind of like where the story starts to build up to my academic journey, because up until that point, I'd left school. I didn't actually study at school. Kind of self-schooled on a yacht sailing around the ocean.
Okay.
And that's kind of where you get to that moment in life where you have to make a decision. Is it going to be a trade where you're going to do something manual? Or for me, it was actually cycling. I was a full-time cyclist. And I got to that point where I realized I needed to use my brain more than my muscle. And that's where I entered into the engineering space. I kind of did a shortcut of actually educating myself to get into university. Mm-hmm. That was pretty tough.
Yeah.
But it actually prepared me for actually, as we all know, engineering it's got a high dropout rate in the first year. What you see in many programs there where you get 100 or 200 people, and probably you will see it by year 2, 20%, 30% remaining. And I started that in Townsville, in James Cook University, where I studied civil engineering through their bachelor program. And it actually has got quite a good geotechnical group there at the time, and continues to be recently good in geotech. So I took that civil engineering degree, graduated, and then aspired to become a geotech engineer. And that's where that experience with the outside world, the love for the earth, started to blend into civil engineering, and that's where I got what was my postgraduate degree, master's in geotechnical engineering science. So that was the start of where I got onto the academic journey.
Okay.
And then really how it took a path from there to go into the professional life. Again, another adventure. It took a journey to actually fly to the Middle East. I flew to Dubai. And started working with Fugro back in 1998. And from that point, really started to actually get into the professionalism of being a geotechnical engineer, logging soil, logging rock, going offshore, in fact, and doing some pretty amazing projects, and taking it all the way to doing the processing of the data, the laboratory testing, and writing reports, delivering the reports and actually backing them up with analytical evidence. And you can imagine over a few years of doing that repeatedly, I built a foundation of what is the art of geotechnics. And literally it's a bit of an art for us because there is a lot of uncertainty. Yeah. There's a lot of uncertainty that geotechnical engineers have to deal with. And sometimes we're considered a bit of a black box, but sometimes we're able to come out with actually quite intuitive interpretations of geotechnics. So, yeah, that was the Middle East, Fugro. I then moved on to another assignment in Fugro, which was in Hong Kong, and a few years in Hong Kong working for Fugro. And if you get to experience Hong Kong, anyone out there, a listener who's been to Hong Kong or the Middle East, you've got some amazing geotechnical arenas to play in, and that's where I got to experience helicopters doing geotechnical engineering up on a mountain on a bamboo scaffold, getting water pumped up in a series of pumps up to the site. In those situations, drilling, I think we were drilling 300 meters, which is 1,000 foot more or less, into the mountain, taking doing pressure meter tests, rock cores, all sorts of great stuff, which was really, really the fun stuff of like how you want to experience geotech in its raw form. And then after that, the journey keeps on going. It arrives actually in Venezuela, where I then go from Hong Kong to Venezuela, and I start to become actually a consultant at that point. And I start to advise on what is the best practice, what is the programs that you would actually deploy for collecting the right data in the right place and actually valuing that data to the end user, which is ultimately the engineer to make a decision, or could be a project director to make a decision. And in that, some wonderful experiences around Venezuela and many other countries in South America I got to touch, being part of the culture there. And then the next step was Houston. So into Houston, for Fugro again, and then being more in a commercial role. So you can appreciate you starting a bachelor, you go into geotechnical engineering field work, you go into more senior roles, and as you get into the commercial space, which is more management. And at that point, I'm taking on a portfolio for Fugro, where in the commercial arena, you're responsible for an area, and that area was South America and the Gulf of Mexico, where we had ships. We do have ships today, which they are active collecting data for clients, for operators to actually make decisions on what they want to do to develop an asset. And those projects were vastly between Colombia, some projects, wonderful projects in Peru, also in Suriname, Trinidad, a bit in Venezuela, a lot in the Gulf of Mexico, all along the coast. And even there was projects even up in Alaska where we'd go up there and actually in certain times of the year kind of work in Alaska, collecting data again and just getting an information base that can be informed for insights and decision making. And then the journey keeps on going. I don't know.
Keep going. No, this is keep going. Don't stop.
But it then progresses into becoming more senior roles actually in Fugro. And that's the beautiful thing about Fugro is you've got this career path, which you can start right at the bottom, right as a graduate. And you've got any career path you can imagine. I could have ended up in a function of HR if I wanted, or others, but I've chose the management path that then led a region of the Middle East. I went back to the Middle East, worked on projects through Africa, through the Mediterranean and, of course, the Gulf of the Middle East, and really just built up a portfolio of understanding what is a business portfolio of managing site investigation projects, managing client portfolios, managing how do you deliver data faster, accurate, how do you actually meet the needs of the client ultimately. And that's that shaping of my journey into becoming more client-focused. So then after a period in the Middle East, it then goes into what is our head office here in Leichendam to then take on the responsibility for a global remit. And that global remit for what we have as a portfolio called Land is really to actually shape the future, shape our strategy, shape our direction with a team into what we will be in 5 years, what we will be in 2 years for a business. And that also touches on key elements of an industry. What is our industry? We contemplate, we actually write down and we strategize about what is the industry needing, where does the industry need to go and need to get better and improve. And we build that into actually a program which then our business can deliver in the different areas of the world, in all regions, in fact. And that's where I am today. We've just finished up our strategy cycle. We have a corporate cycle every more or less 5 years. Released our strategy, and we've got a very clear path of growth and also technology that we're going to be delivering into the market.
Wow, that's really amazing and really exciting. Thank you for sharing that. I think that we have folks that listen in from and watch from all over the world. Some people are students. We have professors. We have folks that are early in their career, first, second year as an engineer. We have contractors, consultants. But I think the reality is that just listen to what you just said. There's a journey that we're on. A lot of times it is not linear.
Never.
Sometimes it may take you to different geologic conditions. It may take you to different, geographic places, different countries, different regions. So it's just really cool to hear that full circle where you are now, because you couldn't be on the planning and visioning side without having had all those experiences that you had. So just really, really, really awesome. And if you could take some time to tell us, what would you say is, because there's a lot to unpack with what you just said, but what are some of the most significant innovations that you've witnessed in land site characterization and geological data gathering? I mean, you're talking about going to sites with helicopters, right? You've seen a lot. So what comes to mind when you think about most significant innovations?
Yeah, there's actually a nice point to reflect on, and philosophically, it can be debated quite endlessly in our industry. But from looking at parallel industries, we can see our industry is actually probably the least digital. We still have a passion for the SPT test, so to love to bang that SPT into the ground and actually get some manual measurements by a driller. We still do a lot of manual management, and sometimes I think the market or the industry out there is a little bit frustrated about the time cycles that are between when you mobilize and when actually the result comes as a report or a borehole log. And those can be in the order of months, depending on the size of the project. It could be weeks if it's a very quick project. And often what we're challenged with, and it goes back to the uncertainty side of our industry, is that you're dealing with geotechnics, which somewhat probabilistically pokes into the ground or does a biopsy of the ground in a hope that they're going to actually hit the actual ailment or the hazard which is actually below the ground. We hope that it's there. And more often than not, we put the foundation outline of what we intend to develop as an asset, and then we align the site investigation program to that footprint. But sometimes, as you would appreciate, that the actual hazard or the risk that you face with the underground is not always aligned with the foundation footprint. And it could be 20 feet off or 50 feet off or 100 feet off. There is something that is dramatically changed, and that can have an overall impact on the performance of the asset underground. So what we're working on and rolling out now is a way to start very early in the asset cycle. So if you look at site investigation is in the phase where you're designing. You want to design an asset, a structure to actually serve its purpose. And what we see is when you're getting into that mode of designing, you're pretty much committed on what is the outcome. Mm-hmm. What you're trying to do is actually find what are the extremities of the data to actually address the sizing perhaps or the configuration of the foundation if you're looking at a built asset. But we're seeing that there is a need to go much earlier, probably pre-FID, pre-finance investment decision-making, and then really screen the site with some indirect measurements. So not going out there and probing blindly, but going out there, scanning it in 3D, getting a 3D model with good resolution, but actually with data that can give you geotechnical parameters. So the one thing the holy grail is in geotechnics is the shear wave velocity. If you've got a shear wave velocity, you ultimately can find a step towards getting to quite a healthy parameter in geotechnics. Mm-hmm. And overall, scanning it in 3D, we've got a solution, SWANS, which we actually deploy. It's passive seismic, so it listens to a vast area of noises, spectrums. So you've got the really low frequencies up to the high frequencies all in the same receiver. And you've probably got in the order of 1,000, at least 500 of these nodes which are listening over a period of 2 days. And we've done projects where they're spread out over let's say it could be a kilometer by 500 meter wide strip of site. Mm-hmm. In the end, by 2 weeks, after screening, we have actually got a three-dimensional ground model, which has got shear wave velocity throughout down to 300 foot. So you can see that early start, even pre-FID, where you can get an appreciation of the trends of the anomalies in the site that you're looking at, then shapes into decision-making, which allows you to say, hey, let's move the foundation, this configuration, let's go for a shallow foundation, or let's go for a deep foundation, or making a combination of those before we start probing, before we start putting CPTs, boreholes down. Mm-hmm. And that insight that you get very early determines a lot of the budgets required for site investigation, for construction, for design, that can then bring forward to then make decisions early, but decisions which are based on really a site-wide data set. And that's really the innovation that I've over my years in being confronted by clients who challenge you and saying, well, you really, really know what is down there? Or in the end, maybe, we're getting more settlement, we're getting these issues on the site. What is the actual problem? Can you diagnose it for me? And it often comes down to the spatial uncertainty that you have between data, mm-hmm. and then also the quality of the data. If you haven't got the right data in the right place and then appreciating what is between it, you'll get a band of uncertainty that impacts all of the decisions down the track. So yeah, that would by far my greatest kind of passion would be around that, and where I see the industry changing.
That's awesome. I mean, that's saturated with innovation. So I love it. Now, when you think about all the things you've done, what do you think's the most memorable project you can think of? I know it's hard to pick I won't say favorite, but
I think those projects where there's challenges. Mm-hmm. Yeah. When you're put up to a challenge, you've got an expectation on you to actually deliver. And there's this type of project, which I can make it an equivalent to, like if Elon Musk is landing a rocket on Mars, you've got to actually, you've got your foundation made on your rocket. You can't really change the foundation. You're going to arrive at this site and you're going to actually land it and found the rocket on the surface of Mars. So in fact, you'll have to actually know what is the geotechnical properties of the ground there to found the rocket on. That rocket's going to be there for a while. And in geotechnical world, there is actually similar projects where we literally within 48 hours of arriving to a site, we have done the site investigation, we've done the laboratory testing, we've done the analysis, and we've actually proven the foundation, like a rocket landing, that it's safe to actually operate going forward. So very high intensity period where these large jack-up platforms for exploration purposes go out to a site, they pin down, and literally that time that they do a soft pinning, as you would probably hover down to the surface of a planet, mm-hmm. you've got to actually go there and immediately drill a borehole, take the samples in the borehole underneath from the rig, and extract all of the data and interpretation out of that borehole, and then within 12 hours go in and do the analysis of the foundation, when it gets into the different load stages of really getting to full load of its operation. And then handing that over to the people that are on the rig move master, and then putting your reputation on the line to say, this is where I believe the foundation will sit beneath the seabed. And then you've got to stay there and wait for it to be proven.
And everybody knows where you're sitting.
That pressure of intensity of really backing your result and standing behind it literally is I would say probably the most profound experience I had in my career.
That's great. Thank you for that. Now, you talked a little bit about the non-intrusive diagnosis techniques that have evolved. Talk a little bit about the impact that they've had on the industry.
The impact is, there's always these great analogies that you can take from parallel industry. And the one industry I do look into often is medical. In the medical industry, if you were before the 70s, you would obviously go into a doctor or a surgeon's place, and you would experience a process of getting biopsies. They would take biopsies, and with the hope that they've actually got the right sample to actually then make a judgment on what is the treatment. And if you go even earlier than the 70s, you'd hope that you'd survived from all of the biopsies, that you can actually live a life. And then in the 70s, what the medical industry ended up doing is they moved into medical imaging, and it started as a journey. It wasn't a moment where the industry just switched, but in the 70s, progressively, what the industry ended up doing is moving towards a proactive way of screening and looking at the body holistically, and then acting on what is the right thing to do. Even to the point now where the industry in medical arenas, they actually use screening to guide even operations. You've got processes where you can actually see what you're doing inside the body while you're doing a biopsy or treatment. Now, if you take that analogy and transplant it into what we are to the geotechnical industry, the transformation from doing biopsies, boreholes, CPTs, getting data, and then I hope that you actually strike the actual problem in the ground happens today. And it's culture that we hold on to dearly. There's an ecosystem which all of us are part of the industry actually are backing. And to change that culture around the world is very difficult. Yeah. We tend to be risk averse in our industry, build in conservatism and probably sit behind a few things. Those that are out there are actually quite challenging. They push the envelope, but in large, we're relatively conservative. Now, to actually make that switch into doing early screening where you can get a holistic view of the ground first before you start probing and biopsying is happening. But like the medical industry, it'll take time to actually get that switching done. But the first adopters will actually get the benefit. And where there's been in the medical industry, for instance, in America, there have been pioneers in some of this. Really, the American industry has benefited a lot in those technology advances. And likewise, in geotechnical space, there will be certain industries, certain markets that will actually say, this is a smart way to do it. It's lowering the risk, lowering the impact, and we can actually deliver, in a hope that mega projects, which have got a brand for being late, over budget, are going to be on time and on budget. And when we get to that stage in the construction industry where mega projects are on time, on budget, there is going to be a more investment that goes into infrastructure. There's going to be more of a belief behind all of those decisions in mega projects. So yeah, it's going to be a journey, but those that adopt early will get the benefit early.
Makes a lot of sense. You want to talk a little bit about the role and the importance of digital models and also forecasting when you talk about geotechnical engineering today?
Yeah. The future around where we are is quite ripe for transformation and disruption. The AI is impacting, I think, all of our lives today. Yeah. Those that actually take on AI are going to be leveled up to those probably that are already of a higher intelligence. So human plus AI will be better than AI alone. And sometimes your human plus AI would be as good as what is an intelligent intellectual. So where we are on ground modeling is philosophically in the same space of that, developing the early site screening model and getting in early so that you can start the journey from pre-FID already have a three-dimensional ground model, which will be having uncertainty attached to it. But progressively, that ground model moves through the life cycle of the asset as it goes into preliminary site investigation, into design, into construction, and then even further into the later asset cycle where they monitor the asset for performance. Starting with a digital model at the beginning becomes a point, a juncture where everyone will actually have a single source of truth, rather than having their set of data in their hard drive, but literally a three-dimensional model where it can be interactive with the surface world. The surface world has got its BIM structure, it's got its structural engineering capabilities. The future is getting into that harmony between the subsurface world and the surface world so that the two can interact. And that point when they can interact with a ground model, as it gets enriched with more data iteratively through synthesis, that you have a way to optimize, you have a way to predict, you have a way to be forecasting on budget, forecasting on time. And those are the big impacts that are going to run through the industry to the point that we get to on time, on budget for many large projects. So digital models, they are the future. They are the evolution that's going to happen, I would predict, in the next 5 years rapidly across the globe. If not, there's a few markets and countries that are already doing that today in largely incoherent workflows. They will have their components of modeling, but it won't be kind of integrated in a single system.
Sounds good. Let's switch gears a little bit. What strategies and technologies have been key when you look at improving data quality in land site characterization?
Yeah, I'm not sure your background on a kind of where you see the industry or even your experience in the field. Do you have any thoughts on actually how things have actually been in the past and how they could be in the future? Because I've got ideas, but I really would like to hear how you see it actually.
Well, I mean, you have more background than I do just because you're seeing things internationally. I think that a lot of my stuff has been domestic. And I think that when we're working on mega projects, we have more, similar to what you said, we have more opportunity to do more than just a typical CPT or SPT. But for the common fare, people need the information now, they need it quickly. And a lot of times the structural engineer or the developer is spelling out what that site characterization looks like. And as a geotech, we're kind of hamstrung. We said we like to do some of these things with, the people are doing in other places, but we can't, right? But when we have that flexibility, especially when we're working on international projects, we could do a lot more. And we could use a lot more of the tools because we have a pretty big toolbox as geotechs, but sometimes we can't use it all because it's education throughout the industry of what it is we're trying to propose.
I totally agree. And what you're touching on is a culture around being very prescriptive in that toolbox. And I think you're touching on a point that as an industry we need to break out of that comfort zone. And I think there's a bit of conservatism by maybe sometimes you feel it's a copy paste, that, hey, this scope is actually just copy paste from some other scope somewhere else. And when we as specialists look at it and you go, really, that is the wrong tool for this application. And by that time, once we're in that mode of actually seeing, hey, this needs to change, there's been already a lot of decisions made before that. It kind of make it inflexible for you to add the value, to improve the data quality or the data coverage, as an example. And this is where I think moving earlier in the asset cycle to actually create a holistic three-dimensional model, pre-FID, that can be shared, integrated with the surface world is the fundamental tipping point, because then you will be able to have AI, which can see the parts of the site which are unique and need to be investigated. And we'll also be able to propose or recommend what is the best way to address the uncertainty related to that risk. And that's where I see an interactive model which is able to advise and offer options is going to be the key turning point of where we'd use rubber stamp copy paste approaches to SI scopes to truly tuning and designing a site investment scope to actually use the right toolkit for the right location. Once we get that sorted, now You kind of question why are we here? Why are we talking about this now? Why are we debating it when we know it's actually the wrong thing? Why are we influencing the decision makers to actually consider alternatives? And I think it's fundamentally coming down to the view from non-specialists in that work with our industry, is the perception of how our industry performs in being accurate in predictions and forecasting. And I go back to the black box that I referred to in the past. Our engagement with many decision makers, stakeholders who are higher up in projects, they see the geotechnical world as a black box, like an art, a science. And they don't understand. And the black box represents their inability to understand what's happening inside. Yet we're able to actually live in a world which is virtual, understanding boreholes in 3 dimensions under the ground, understanding things on paper in 2D. We're able to craft an interpretation in our minds of what is it telling us. You try and do that with these stakeholders, they actually see, hey, this is witchcraft. This is kind of like in that realm of, okay, I trust you. Are you following the ASTM? Are you following the AASHTO code? Okay. As long as you follow that and you get the box, I'm okay. But come out of that black box and give us a result.
Yeah.
And I feel that what we've got to do as an industry is break down that black box so that we can build trust with all of those other engineering stakeholders and decision makers that allows us to be relatable, that allows us to be predictable, rather than, oh, I got a surprise for you.
Or you brought the bad news. Yeah.
I got some bad news for you. It's all like the doctor giving you bad news. But I think philosophically, that's actually where we struggle as an industry to get the right things done in the right place. It's because the decisions are made in the belief that actually, will you get like a bang for your buck out of site investigation? Maybe not. Let's just copy paste and hope that we pick up something, but the construction will handle that and engineering will handle that in its structural design. They will do a safety factor and it'll be fine. We'll sail through this. So yeah, I think it's part of us to actually reflect on what we are as an industry and what we do, how we act.
That's very helpful. And I think that really speaks to the work that are being done by, professional organizations, and just, making sure those conferences, it's not just us talking to us,
yes,
but that we have something that's going out to the industry so that, other folks in the team have an appreciation for what we're doing. So I completely agree with what you're saying there. And from your perspective, what do you think are the biggest challenges when you're looking at large-scale geotechnical projects? What are some of the largest challenges to how to manage those?
And the biggest challenges come into the mega projects. By far, schedule and budget is the biggest influencer. And those surprises that come out of the black boxes are what we as an industry actually struggle with. Yeah. And more often than not, you'll find the decisions making early about the ground from assumptions that are actually then sometimes, to meet those design requirements or the FID decisions, our industry is forced to actually say, okay, you have to make this work. You have to actually find a way to make this work. You don't get this working, we have a lot of problems.
Yeah, we don't have a project.
We don't know how to get there.
Yep.
And you find more time and time again, we as professionals get squeezed or put into a corner where this has got to make it, you got to make it work. And then we go iteratively around finding ways to actually solve the problem, but it's too late. That is really kind of the milk is already spilled. Yeah. And that can happen when it kicks into construction, and the constructor finds a problem. Now, the industry is also siloed, so the risk is siloed, and the constructor tends to say, hey, I'll take that risk on because I'm going to make a buck out of it. And if there's any deviation from what the site investigation has told us, I'll put my hand up for a claim. And these buckets of silos can actually be counterproductive, even though that we seek to actually harmoniously deliver a project. But the discoveries that come in later in the project often actually bite us badly. And I've come across cavities in the ground. I've come across really soft soils in the ground. You can actually have aquifers that have a high pressure can actually really disrupt the foundation's performance. You've actually seen where one part of a foundation is operating really well, yet the other part of the foundation is having problems with settlement or even cracking. And those are situations where obviously there is a spatial uncertainty which hasn't been addressed. One part of the foundation wasn't properly modeled because the ground wasn't sampled in that place. And then it comes down to even in site investigation and the quality of this. Even doing an SBT, you can get it wrong, despite where our beliefs you can't. It's fail-safe. Even in the laboratory, there's so many dependencies in site investigation where doing a measurement in the laboratory, you can get it wrong. It needs forensics to actually work out what is the data telling us. So yeah, there's a multitude of ways where projects can go wrong. And that's where moving earlier pre-FID during site screening, you start with a single source of truth. And then from that point on, you aggregate and get to a more refined ground model.
All right, thank you for that. And how would you address, this is something that I know comes up, right? How would you address scope creep in projects? And what are some strategies for how to manage projects with optimistic timeframes and also to ensure timely delivery? And you hinted on some of this already, Leonard, but what are your thoughts there?
Yeah, there is a few models. And when you talk about scope creep, I'm thinking at the higher level of the actual assets creep. So that's actually the design or construction and the delivery of the asset. And that asset can be anything from a building, it could be a bridge, it could be a tunnel. And really when you sit back and look at the industry, there is this silo effect. And I referred to it before. When there are distinct silos where risk related to a project, and risk will actually impact your scope creep and your budget and your time, your cost overruns. When you actually have these silos, there is somewhat hidden risk which is thrown over between the silos. And those silos could be from preliminary design into detailed design. It can go from detailed design into construction, and then from construction into operation. So those are the principle. And those hidden risks are often what actually compound. And maybe might be an optimism in the design or optimism in the construction methodology. And it's about getting the risk down so that collectively you can actually share the risk. And you can only share the risk when there is an owner of the asset which takes the responsibility to manage through and observe and check and ensure that the risk isn't left residual for the next stakeholder. So really, from the higher level, when you're at an owner, this is really the big responsibilities. How do you manage the risk to an acceptable level that you can move forward without actually causing a future pain, future creep? And that can apply into site investigation. You know, when you do a site investigation, you're out there to actually focus on a particular area of an asset. And that means you have to actually design the site investigation for its depth. So what is the foundation influence depth? But you've also got to find the sweet spot in the ground at which the foundation is most active. So that means scheduling your in situ tests or your laboratory tests within the depth that is critical for addressing that particular load or a particular movement in the ground. So in site investigation, we can actually have scope creep where it gets passed on, this residual risk, by not designing the right site investigation. You touched on it before. Sometimes you just go in there blind. You're told you have to do X, Y, Z. You do it. You actually have to back your result, but then you qualify it. And what ends up happening is we qualify it, quantify it, and say, hey, this is what it's saying, but be aware of this risk caveat. So all of the elements are really needing to be put into a harmony between site investigation, design into construction. And the only way is through the owner-operator, just to take that and to listen to the specialists that are in that domain. If you're in the phase of site investigation, then the owner to listen to that domain and really, really, really tune in to actually what does it mean for me? What does it mean for the project as a whole? Am I willing to actually accept this risk and carry it forward, or do I really want to bury it? And I go back to the philosophy of how we need to improve as an industry and get away from that black box, because for the owners to actually get comfortable with the risk and to not incur further future scope creep because of risk, we need to be able to have a transparent way to work that they understand literally what we're talking about, what we're actually concerned about, what is the fatal flaw situation. Yeah.
That's very important, because then it's not, just us making decision. It's decision as a team. It's like,
yes.
Oh, by the way, because this impacts this and this impacts that, what are we going to do? Okay, great. Well, before we take our break, Leonard, what's the piece of advice you want to offer geotechnical professionals and those that are aspiring to advance in their careers? What's the piece of advice you want to give them before our break?
Yeah, I'd like to actually hear the answer from you, because I've got an answer that, there is everyone has a background and a journey that you've taken. So for you, I'd like to actually bounce off what you have and what I have, and we can compare our kind of philosophy, I guess, in life learning.
I would think that for me, it's kind of two things that come to mind. One is to remain curious. You never want to get to the point where it's like, oh, I have my advanced degrees or I have my license, I know it all. We have to remain curious. In order to really provide value, you have to be able to think outside the box, and thinking outside the box requires you to always want to know more about things. So having hobbies is a part of remaining curious. Raising your hand before you know how to do something and having to figure it out is remaining curious. And I think that as a geotech, some of the best geotechs I work with around the world were very curious. They remained curious. Even those that have been doing this 40, 50 years, they were still curious. Those are the ones I thought were the best. And then I would couple that with the notion of just listening. It's so important, especially as you become more responsible for people within an organization or within the industry. Listening is so key. And I think that some of the best mentors that I've had over the years were very good listeners. So those are two things I'd say: remain curious, and I'd say listen.
I back that up 100%. In fact, my career has been about curiosity. All of those experiences and journeys I've had around the world, it's been from a curiosity that I've wanted to know more. I've wanted to actually understand better. I would like to back up the curiosity with kind of the philosophy on how I've taken on my life. And there's two things. There's the values. What are your values? Know your values and stick to them. And one of the fundamental values is build trust. If there's anything, and you go back to working as a team, whether you're in a project team or you're in a family, build trust. Always believe the right intention is going to be there from others, and you have the right intention. And then the other one that plays very well, because often we will get challenged in our life, and our curiosity will lead us to a point of decision making. But the thing that we will get challenged with is our value. So you have values, what you believe your life in, but know your value. If you are curious, you'll come to conclusions, you'll be able to deduct, formulate a decision, but there's going to be people who are going to challenge you, for sure. And this is part of the journey of life. If you know your value and why you're at the table and what you're bringing to the table, then you're able to confidently back it. And don't let others, and this is a key point, don't let others define your value. So, you don't want someone across the table giving an opinion and then suddenly you change your value for what you think you are. Take the feedback, listen definitely, and always observe what is around you and be curious, but know your core value. What is your core value to what you do?
Love it. That's good. We got a lot for people to chew on. So thank you so much. We're going to come back in just a minute, and we're going to close this one out with Leonard and our career factor of safety end segment. All right, welcome back. It's time for our career factor of safety end segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your actual career? So today, of course, we're speaking with Leonard Sands from Fugro. Leonard, you've had a very successful career. Now, when you look back on your career, what's one thing that you've implemented in your career to give yourself, I don't know, let's call it a factor of safety in your career?
Well, that's a challenging question, and you have to dig deep to actually work out what is really the thing that, I guess what you're touching on is defining your ceiling. You could hit the ceiling and bounce off, and then have to recover again. So I would really say that there's two parts to people, and then I'm touching more on philosophical approach to life, because there's the personal and there's the professional. And whether you like it or not, your professional life and your business life, or what you're doing, even academia, is an abstraction of your personal life. You actually live your personal life every day. It doesn't turn off. It doesn't switch off. And often what we do is that in our professional life, we have a little box that we actually say, okay, I'm in a professional environment. I'm going to actually have a stiff back, and I'm going to actually turn up, and I'm going to be like this, and often we put a bit of a shield there. And that shield is actually designed or created by the box of personal experiences that we've chosen to put a cap on. And when we actually hit ceilings in our career, when we kind of, as we're growing, those ceilings which limit our growth are more often than not defined by that box of issues or challenges that we've kept closed. And it's about us actually creating the ceiling, and it's not the world around us. The world doesn't really define the ceiling to your future. You can actually have the future you want. It's about you and how you turn up to the world. And if you're able to be comfortable with opening that box of challenges you've had in your life and actually talking about them, regurgitating them and walking through them, you will find that your journey through life will be easier, happier, and you'll come across very few ceilings that you perceive generate frustration for your next step. So it's one, the curiosity. Two is dealing with those issues which are in the box, and go deep. Don't be afraid, and work on it. And you'll actually have a successful personal life and a successful professional life, and what you get into a happiness state. Yeah,
man, that is powerful. Thank you for that, Leonard. That was powerful. So thank you for coming on and for sharing all the great insights with us. You shared some really good information and advice that's going to be helpful for those that are listening and those that are watching. Now, if somebody wanted to reach out to you, where can people find you? Are you on social media, your website, or email you want to share? We can put in the show notes. What's the best way for people to find Leonard Sands?
Yeah, certainly. You can find me on LinkedIn. So Leonard Sands. You'll see that under the profile of Fugro, working there. But even I'll have the email that I can share in the comment section for you. So really welcome any inspiring geotechnical engineers who want to kind of get some direction or guidance, or even an opportunity in the world. Reach out. More than happy to help.
Okay, excellent. No, this is great. Thank you so much.
Thank you. Appreciate it.
I hope you enjoyed the episode for today. We would love to hear your feedback, comments, and or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all of your geotechnical engineering endeavors. Peace.